Today we will be looking at multi-step sig fig calculations. And most years this would be something that everybody learns, but today, this year rather, because of our weird system, this is going to be for our 3% club. Okay? This is something that will be useful to you in grade 12 for certain. Definitely if you go on to university sciences. Okay? All right, so let's start with, actually, just before we do that, let's make sure we remember our rules. And that means that our addition and subtraction rule is we round to the first uncertain digit. And our multiplication and division rule is that we round to the lowest number of sig figs. Okay? And when we're doing multi-step sig fig calculations, you are going to use the following rules. And the first one is you are going to follow the order of operations. Which is, hopefully all of you know, BEDMAS, brackets, exponents, division, multiplication, addition, subtraction. You are going to use those sig fig rules, these ones up here that we just talked about, but you are not going to round off in each step. You're just going to keep track of them. So you're going to use sig fig rules for each step, but you're not going to round off. Do not round off. Just keep track. This means you're going to be writing out your work. It's not impossible to do these multi-step without writing out your work, but it's darn hard. I find I have to write it out. If I have to write it out, you're going to want to write it out. Okay? Write out each step separately. So like I said, you're going to be writing it. Write out each step separately. Keep track of your uncertain digits and sig figs. So keep track of both. Uncertain digits and sig figs. And then finally, you are going to round off only at the very end. Only at the very end. Alrighty. So let us do an example, which is not too terribly difficult, but makes us exercise these principles. So we have 6.8 plus 9.2 divided by 3.65. Okay, and we are going to follow our order of operations, so that means we are going to do our brackets first. So that's going to be step number one. We're going to do our brackets. So we have 6.8 plus 9.2, and that is equal to, if we put that in our calculator, we get 16. Now, we are adding, so remember you are going to go to the first uncertain digit, and that means we need to know who our uncertain digits are. So we have our 8 is uncertain, our 2 is uncertain, that's our first decimal place. That means that this number, this 16, actually needs a first decimal place because that is its uncertain digit right there. So that means in step number one, our brackets, we actually in our final answer have how many sig figs? How many sig figs would this be? If this were our final answer, how many sig figs would we have? We would have 3 sig figs. Bear that in mind because our next step, step number 2, there's no exponents, so we don't have to do the e. There is, however, a division. Okay, we have a division. So we will do next our division. And that is going to be the top part, which is 16.0, we decided. Whoops, there we go. And we're going to divide that by, let's make that look like a 0. 16.0 divided by 3.65. And remember that this number here has 3 sig figs, and this number here has 3 sig figs, because when we do a division, we go to the smallest number of sig figs. And in this case, we have 3 sig figs and 3 sig figs, so our answer should have 3 sig figs. So we can plug that into our calculator. We get 4.38356, blah, 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 blah. Okay, you get a whole bunch of digits after that. But we want to go to 3 sig figs, 1, 2, 3. And we look at our number to the right of that, and that's less than 5. So we're going to not round up. Sorry, crinkly wrapper there. And we will get 4.38. And at this point, I would put a box around that because there's a lot of work in there. And it's helpful to say, this is my final answer. Okay, let's do another one. We have 50.35 times 0.106 minus 24.37 times 0.181. Okay, so again, we have to do order of operations first. There are no brackets, no b, there's no e, no exponents, there's no d, division, but there is a multiplication. And of course, division and multiplication doesn't matter the order, but here we're going to do our multiplications first. So we're going to do our multiplication here. Grab a different pen here. We're going to do this multiplication, and we're going to do this multiplication. So, multiplication. Okay, so we have 50.35 times 0.106. Plug that into the calculator, and you get 5.3371. Okay. And now we're going to need, because this was a multiplication, remember you are going to say, if this were my final answer, I would go to the least number of sig figs. Okay. And so we're going to look and we're going to say this number here has 4 sig figs. That one's pretty easy, 4 sig figs. And don't forget, zeros on the left are never significant, so it's no, yes, maybe, and this one is on the left-hand side, so that is a no, that is not significant. This one in the middle is significant, so that's a yes. So we have 1, 2, 3 sig figs, 3 sig figs, which means if this were my final answer, I would want to have 3 sig figs, and I would round off to 5.34. But remember, I wrote it down twice. Do not round off for each step. Okay? Only round off at the very end. So we are going to somehow note for ourselves that this number has 3 sig figs. And I'm going to do that a couple of ways. I'm going to mark my uncertain digit, and I'm also going to write down that it has 3 sig figs. Okay. Our second multiplication, so let's call that multiplication A. Here we're going to have multiplication B. This is our second one. This is our 24.37, the second half of the question here. So we have 24.37 times 0.181. Calculator that sucker, and we get 4.403659. Woo, lots of digits there. And because this was multiplication, again, you're going to go to the least sig figs. So we look and we say I had 4 sig figs in my calculation. And I had, remember, zeros on the left are never significant. So I have 3 sig figs here. And that means the lower of those two, 3 is less than 4, so we're going to go with 3 sig figs. And again, will I round? No, I will not round because I don't round until the very end. But I will keep track of my uncertain digit, and I will keep track of the fact that I have 3 sig figs in each of these. Because now what I want to do is I want to grab a different color here. I'm going to take that first part, 5.3371, which is equal to the blue thing I just highlighted, and I'm going to subtract the green thing. Yeah, here's my green thing. Okay, and so I'm going to take my blue thing, 5.3371, and I'm going to subtract the green thing, 4.403659. Okay, and so that's my blue thing minus my green thing. And remember, I'm keeping track of my uncertain digit, and I'm keeping track of the fact that I have 3 sig figs and I have 3 sig figs. I plug this into the calculator, do my subtraction, okay, because that's next in our thing, and we get 0.933441. Okay, and this is a subtraction. The rule for subtraction is we go to the first uncertain digit. And our first uncertain digit is in the hundredths position, the 0.01 position. So that's going to be in the hundredths position right here. That is our first uncertain digit. And so we're going to round to that. So our final answer will round to 0.93. And I'm going to box my final answer. Okay, and that is it for that question. You might want to take a little brain break for a moment. If not, we can just carry on. Okay. This one's going to have some exponents in it just for fun. Okay. So, for example, we could have 1.086 times 10 to the minus 2 minus 9.754 times 10 to the minus 3. That's all on our numerator. And then in our denominator, we're going to have 2.7002 times 10 to the negative 4 plus 5.013 times 10 to the minus 3. Now our order of operations says brackets first. If you have an underline at like that all over, that acts like a bracket for everything on the top, and it acts like a bracket for everything on the bottom. For everything on the top and everything on the bottom. So we could, if we wanted to, rewrite this as square bracket over all of the stuff on the top and square bracket over all the stuff on the bottom. But because we have that line there, it is unnecessary to do so. So I'm just going to erase that again. But that's what it really means to have that line there. Okay. So what that means is that all the subtraction on the top is going to be a bracket thing. So we're going to do that first. So number 1 we are going to do 1.086 times 10 to the negative 2, and we are going to subtract 9.754 times 10 to the negative 3. We are adding and subtracting, and we have exponents. What do you have to do before you add and subtract things with exponents? With powers of 10. Powers of 10. Hopefully you remember, they must be in the same power of 10. Because you're adding and subtracting and you need your first uncertain digit, all the decimals have to be lined up. And if your powers of 10 are different, your decimals don't line up properly. Okay? Now I'm going to follow my general rule, which is to convert everything to the higher power. So we're going to have, I'm going to keep 1.086 times 10 to the negative 2. And I'm going to subtract. Now I want this to become times 10 to the negative 2. Okay. And this part of the number got bigger by 1 power of 10. Okay, it went from negative 2 to negative 3. So this part of the number must get smaller by 1 power of 10. So that means it has to become 0.9754 times 10 to the negative 2. Okay, and if you remember, you can either just plug this into your calculator, or you can say I have 1.086 minus 0.9754. Oh no, you have to. So you would take, you would take 1.086 minus 0.954, and that would all be times 10 to the negative 2. This you would plug into your calculator, and you would get 0.1106 times 10 to the negative 2. And remember, we just did, what kind of an operation did we just do? We just did a subtraction. So we have to go to the first uncertain digit, which means our first uncertain digit is in the tenths, hundredths, thousandths. It's in the thousandths position, and so is the 4. It's in the thousandths position. And so we need to say, oh, there's our thousandths position. Okay? And this is going to have, so remember, we're keeping track. Keep track of the uncertain digit. Keep track of the number of sig figs. This would have 3 sig figs if it were our final answer. But we're not going to round off yet, because if I was to round off and use 0.111 in my next calculation, my final answer might actually get rounded to a number that's too big, and you would have a rounding error. We'll look at what that looks like a little bit later. Okay? So that was the numerator. That was all the numerator. Numerator. Second thing we're going to do is the denominator. Ooh. Because we've got now our denominator down on the bottom, 2.7002 times 10 to the negative 4. 2.7002 times 10 to the negative 4. And what were we doing with that? We were adding to it 5.013 times 10 to the negative 3. Adding to it 5.013 times 10 to the negative 3. Okay. And again, I'm going to because I am adding and I have different powers of 10, I must convert to the same power of 10. So I'm going to convert to the larger power of 10. So I'm going to take my 10 to the negative 4 and turn it into 10 to the negative 3, because I'm going to make it the same as that 10 to the negative 3. And because this got bigger, that means this part of the number has to get smaller. And this got bigger by 10 to the 1, okay, 1 power of 10. So this has to get smaller by 10 to the 1, which means we're moving our decimal place 1 position over. So that's going to be 0.27002 times 10 to the negative 3. So now we have 0.2700 times 10 to the negative 3 plus 5.013 times 10 to the negative 3. And remember, we are going to take the coefficients and add them. So we have 0.27002 plus 5.013. And all of that is going to be times 10 to the negative 3. Toss that into the calculator and we get 5.38302 times 10 to the negative 3. Okay. And are we going to round at this point? Are we going to round off? No, we're not going to. But what do we have to do? We have to keep track of the uncertain digit and the sig figs. So in this case, our uncertain digit is the 2 and the 3. So that is in the, I don't know, like what, 100 thousandths position. That's tiny. This is in the thousandths position. So our uncertain digit here is going to be the 3. That is our uncertain digit. And what that means is that we have 4 sig figs. So now this is our denominator. Okay. So our numerator, I'm going to go highlight that in blue. Our numerator, and I don't care that it's not in scientific notation at this point. I'll worry about that at the end. Okay, so our numerator, 0.1106 times 10 to the negative 2. 0.1106 times 10 to the negative 2. Sorry, there's this button on my pen that's like right where my thumb is. I'm going to try turning it around and seeing if that helps. Times 10 to the negative 2, that's our numerator. And our denominator, oh, we just solved for that. Here's our denominator. Okay, and we're going to put that on the bottom. That is 5.38302 times 10 to the negative 3. Okay, there we are. And we'll do that division. Oh, and remember, we are keeping track of our uncertain digit. It's the 3 in this one. There's our uncertain digit. Remember, that is 4 sig figs. Keeping track of both. And going back to our other number, it's the 0, and we have 3 sig figs. Okay. So our uncertain digit is the 0, and we have 3 sig figs. So this can just, when you're multiplying and dividing with powers of 10, you can just throw it in your calculator. You don't have to do the coefficients separately. Okay? That's only, you do the coefficients separately when you're adding and subtracting. So toss this all into the calculator, and we get 0.2054609. Whew, that's a lot. And we just did a division. And when we do a division, we go to the least number of sig figs. And so out of 3 sig figs and 4 sig figs, the smaller number is 3. So we're going to go to 1, 2, 3 sig figs. And so that then is going to round to 0.205.